All right, thanks all for coming. It's nice to see a full room. First of all, around me, I'm Lyaruu. I'm from the city of Amsterdam, and I am not affiliated with Oracle, who makes ADBA, or Pivotal, who makes R2DBC. So I'm just me, and I don't know more than any other person in that sense. So. Our JDBC, ADBA, reactive SQL drivers are coming. And a very sensible follow-up question would be, why should I care? And that usually follows out of another question, and that is, what is wrong with blocking code? Because we have been writing a lot of blocking code and for a long time, and apparently it works. So let's take a little bit of an example here, right? So. This is a servlet, really like kind of old school. I deliberately try to not use any fancy things here. A GET that connects to a database, right? You open a connection, you create a statement, you get a result set, you loop over the result set, and for every result line, you write something to the output of the servlet. I think most of us have made these things, lots of them, right? So the world is filled with those. So what is wrong with that? Well, I think there is a case of what we call leaky abstractions here. Because if we, and a leaky abstraction, I don't know if you all know it, but it is in software that when you abstract away something to a higher level, so it's easier to work with, but that abstraction doesn't work 100%. Maybe 95%. Usually it kind of works, but sometimes you do need to know what's underneath, right? So, so that's, yeah, you can't really ignore that. So, what I would, for example, here, first of all, when I create a connection. Honestly, that is not really true. You can't really create a connection. You can ask the operating system to send some package down the line, and then you can wait until some packages come back. And if you like those packages, you can say, well, we have a connection. But it's not something you do, right? And how they model that here is that you send those packages, and then you wait. And you wait, and you wait until you get some kind of reply. The same goes for executing the query, right? You send the query to the database in some form, and the database does its thing. In this case, it won't take long, but maybe in some case you call some fancy stored procedure or something, it can take an hour. But in the meantime, that thread, that call, that sits there waiting, staring at the socket until something comes out. And that's not trivial. After that, we loop around. Well, first of all, the result set next has the same issue. Because if you ask the database, OK, I'm ready for more data, and then the database will say, well, here you go. But again, that involves a lot of waiting, because there's a round trip to the database involved, right? Finally, when you write to the output stream of a servlet, it has to cross the network towards the client, right? So that will also involve waiting. You can't just shove all the data you want through the line. It needs to balance it out with what the network connection or the client can take, right? So, is this a problem? Well, not always. And in quite a lot of cases, it apparently isn't a problem. The question is more like, can you afford it? Right? It is, and I think a good way to look at it is when you would have a car with a driver, right? Like a fancy person, you have a lot of money, you can afford that. And for that person, that's amazing. You just go places and you say, James, leave the engine running. You just go do your thing. You can get drunk, doesn't matter. You can leave your stuff in the car. And when you come back, the car is still there. You go to the next place. It's a really nice way of living. But as a system, that is problematic, right? Because there's a lot of waste. There's a lot of waste in the sense that there is stuff that sits there waiting for you doing nothing. And at some point, those resources are finite, so you are going to run out. Yeah. So another issue that can happen here in this same example is that what if the database slows down a little bit, or a lot, but we don't really know why, but somehow the database slows down. Let's look at an example. We have this thing runs. There are about 1,000 requests per second. They're just numbers, just made it up. There are about 1,000 requests per second. Say the database query takes 8 milliseconds. The whole service with the stuff that we did in the servlet is 10 milliseconds. So from that calculation, that means more or less 10 threads or something, right? So that's all right. Okay, and if you have 10 threads to spare, it's all fine. But what if the database gets slower? For example, it takes quite twice as long to make a query. Then, if you take an easy calculation, then it will be like 18 milliseconds per service, and then all of a sudden we need 18 threads. And that in itself is a little bit scary, because we do the exact same thing, but we use more resources for it. And that will lead to more congestion, because like threads are definitely not for free, right? And it kind of starts to sound like, well, traffic is bad, so if I have, for example, like a delivery service, I need more cars because the traffic is so bad. And obviously, the traffic is so bad because there are so many cars. And if you have that kind of circular situations, that is scary, right? So another way to look at this is that we don't control the number of requests that come in. Not really. We also don't control from the application service point of view how long the database query runs. So that means that we also don't control how many threads we are using. And again, that's not a joke, right? Because if things go bad, then things fall apart. We can't really solve it from that perspective. So also that means that in this calculation, I sort of assumed that the server itself is not affected with it had like the 2 millisecond overhead before, right? And now it's using more threads. It does the same work, but it might be much worse than this, right? Because the more threads there are, the more memory is taken. Maybe at some point the garbage collector goes crazy. So it might be much worse than this. And again, then you have like the circular effect because that it gets worse because it gets worse, and then things go wrong. So can't we just cloud native ourselves out of this? Well, from this particular problem, a little bit. If we have like more requests and we have maybe a Kubernetes or something that manages that load, and that can conclude, well, we need another server, because look at how busy this one is. And yeah, we can do that. And that will, at this point, solve our problem, because then we just need more machines. And if we have to explain to upper management why we need another server, we just don't look at that server like so much CPU and memory is doing a lot. And it seems busy. It is not really. It's waiting for databases. But it seems it's easy to sell. And like, I guess Amazon and Google are really happy with this, because easy money, right? And at some point, we get used to that. So there are some ways to mitigate it. And that's basically what every sane developer does, and also pretty much every application server, for example, limits the amount of threads that gets into the servlet code itself. So if 1,000 requests arrive at the same time, it doesn't try to make 1,000 threads at the same time. Mostly they limit it to something like 100 or something, so at least the system will sort of survive. But that does shift the problem away a little bit, because what happens then is that we, at some point, we have more requests than we have threads, so they queue, right? Fair enough. And at some point, first of all, queuing also takes memory, so that's not really solving the problem. And it's finite, so at some point, if we have too much, we need to drop requests. But also, in this case, it's kind of simplistic because there's only one kind of request. But if we start queuing those requests, maybe not all of them need the database, right? Maybe there is some caching layer here, and that if it's a cache hit, then you don't need the database, so you can go straight through. And if the cache missed, then you need to go to the database. Theoretically, you only need to queue the ones that go to the database. But if you just have a blocking situation, then you can't really put any logic here. You can only block everything, right? So we are not really really solving the problem, right? We're really solving sub-problems, and then there are a little bit smaller problems behind that, but we never really get to the core. To get to the core, you have to consider non-blocking code. And non-blocking code is really, really not very new. But as a summary about blocking code, in many situations, don't forget, blocking code is just fine. If you can afford to have the number of threads waiting that need to do your work, you're good. And then if you would take an application that's doing fine in blocking code, and you convert it to non-blocking, you won't gain much. Maybe a little bit, but generally that wouldn't really matter. But at scale, performance can be an issue. Threads are really one of the most valuable things that are in your system. You can have a lot of CPU and a lot of memory, and that scales quite nicely, but threads, not so much. I mean, you can have hundreds of threads, maybe thousands, but after that, it gets really painful. And also because the moment there's downstream a problem, our number of threads blows up, and then you can get stability issues. Especially in our new age of microservices, that we chain all kinds of services together. One piece of code might be blocking more than one thread, right? Because maybe there's another blocking service waiting for that, etc., etc. And that means that it's really unpredictable how that's gonna behave. And we often use like circuit breakers and so on to kind of mitigate that a little bit, but it doesn't really solve it. So non-blocking APIs are not new. There have been even some database drivers, but HTTP clients has been around forever. The NIO code for Java was around for a long time. And also the Servlet 3.1 has been around for a long time. And somehow none of them are very popular. And I think that is because they really painful to work with. And the example I usually use for that is from the non-blocking servlet API. This example is an echo servlet. It's a little bit of service, you push some data to it, and it just gives the same data back. It's kind of the hello world of services, right? So you have a little bit of a buffer, you get some data from the input stream, right? As long as you have data, and then you write it to the output stream, and you loop and loop and loop until you're done. Easy. It's easy to explain. If you look at the code, you say, yeah, that sounds about right. If you take the non-blocking version using the non-blocking API, yeah, that's a different story. And not just that it's like, I don't know, 5 times more, but it's really very complicated to walk through what exactly is happening now. So I suspect that that's a big reason that those APIs have been around forever, but they were not very popular. So, and I think that's because callbacks. All those APIs use callbacks to, when you schedule something non-blocking, when you're done, you need to tell the original code somehow, and you use a callback. We have been talking about a lot this few days. Also callback hell, right? If you have a lot of non-blocking code next to each other, every time with blocking code, you just use a semicolon and you do the next instruction, right? And that's nice and straight. But here you have to you nest them all together, and at some point it scrolls on the right side of your screen, and then you are unhappy. But what changed lately is that there are new programming models that don't use callbacks, or not much at least. And those are completable futures and reactive streams. Are they familiar? Yeah, I see nodding heads. That's good. So first, completable futures. Well, let's start with futures. They have been around also for a while, and that's like they're like kind of second-grade futures, because what you can do is that you have some non-blocking code, and that does something, and that returns a future, and that's a container that will at some point contain the value that returned. You can ask that thing, is it already there? Yes or no. It will return yes, true or false, and you can do get. But the problem with get is that it blocks. So it means wait until it is there. And then you're again blocking your thread, so you're not really progressing here. Also, you could, of course, hammer it on and call it over and over and over again until it's true. But that's even worse than blocking, because then you're live hammering away at that method. So that's even worse. So that also never really caught on, because you end up blocking just a minute later, a millisecond later or something. In Java 8, we got completable futures, and they extend futures, so they're nice and compatible. But what they do is that it will tell you when it's done, in a nutshell. You can use a sort of callback for that, but the nice thing about it is that if you have several of those completable futures, you can chain them together. You can say, do this, and that will return a completable future. And when the value arrived, do this with it, right? So here I have two completable futures, completable ID and a remote, so like an ID, and then you query the result of it. And then I can use the compose. So I get first the ID, which is the future, so it's not really there yet at this point. But then when it arrives, then you do this, and when this arrives, you do a then accept, and then you write it to system error. All right? So that's how you can. It gets a whole lot more palatable to use these. Reactive streams are a similar approach. They're a bit like a completable future, only that it has potentially many results. The completable future only has one, right? It's there or it isn't. But here we can have a lot, 0 to n. And it's a specification, so there are many different implementations. And for example, we have RxJava is pretty popular, Spring Reactor, of course, Akka Streams, Vertex, and I probably forgot a few. But all they have that model that you have a sort of a stream of results that will show up at some time, at some point, and you can chain those together just like in a completable future. Here's a small reactive streams example. This is an RxJava one. For example, I use an asynchronous HTTP client. I call a service, like I can ask the weather for Krakow, and it will probably mean that's hot. And then this will start spitting out blobs of byte arrays, so just data. It doesn't know what it is, but it's just pieces of data. Then the XML parser takes those pieces and consumes those and spits out XML events. Then I say filter, I only want the XML start events, and I only want where the body is equal to temperature. Then I get the attribute of that temperature, and then I take the value. And then so now I have a method that will at some point spit out a number. And that's basically in a nutshell how the reactive streams work. So that reactive model and generally the non-blocking model has been talked about for a long time for relational databases, because there is not really a reason why there shouldn't be. But it has been taking a long time. The oldest link I could find was 2016, but I'm sure there was more, but I can't find it anymore. It was called JDBC Next first, and later ADBA. And that's a project of Oracle, but it's yeah. So it would be really nice if Oracle really adopts the standard. But right now, I haven't found a single talk about ADBA outside of Oracle. I only have seen Oracle people talk about it and or write about it, or it is really pretty obscure. So, and it's also still quite new. It's really not done yet. and it seems that the API is also not quite stable. So I have some examples. I put them on GitHub if you want to play with those. I think if you want to dive into it, it can save you some time. I will get into that later. But let's dive in and see how we can use that original example and use ADBA for it. So first attempt, creating the data source and use a nice fluent API, all great, not that exciting. We create a session, that's apparently what we do in ADBA. And what happens then is that we do a row operation. That's an operation that will return a list of strings, in this case, right? So, and the list of strings, from there I can use the stream API to collect it. And what I just do here, I take an array list, and for every row I add the right piece of, the right field to it, and then I submit, so that then it actually starts. I get a completable future. I don't know why I need two of them, but okay. And then finally, when it's done, I have a list, and I loop over the list and write it to standard out. So, and then I also need to block, because it's the synchronous servlet, so otherwise it will close the connection. So this is not exactly pretty, and there are a lot of issues with that. For one, if this result is big, it tries to keep it all in memory. That we didn't do that before, and so that's a little bit worse. Also, we are blocking the thread that's calling the servlet, because it's a regular servlet. So actually, we're using more threads than we did before. We're blocking the original one and also some other thread that's doing the actual work. So that's not really an improvement. So let's try again. Creating connection the same. But now let's write it straight to the output, right? So instead of creating a list, we just go straight inside the collection, we write it, and that saves us the memory overhead. But still, we need to block because it's still a regular servlet, right? So we still are wasting that thread that sits there doing nothing. All right, let's try again. Next up, we can use asynchronous servlet. That is basically from servlet 3.0, and that means that we create the context from the request, and then we say basically, it's okay to leave this method. This connection will stay around until we complete this context. So for the rest, we do the same thing. We do the query the rows, we write the rows, and we submit it. But now we can do then accept. So when this is complete, when the query is complete, we say to the context, okay, we're done, close everything, and now we don't need to block anymore. So now we actually saved some thread time. Not much, but something. Yeah? So, but there is still blocking going on. And the blocking that's going on is the write action here that writes to the client. Because that still might be a mobile phone in the middle of nowhere, right, with a really shitty throughput. So this thing will just block here. And we would like to use a non-blocking write. Non-blocking write, but if you think about it, it is kind of weird, because if we would just make it naively non-blocking, so it will just accept the data and just return immediately, this thing will just pump everything it finds as fast as it can go through that line. And that might not work out, right? Because if you have a non-blocking API, you need to have some kind of control. So for the non-blocking servlet, we have the servlet output stream. We can add a write listener to it. And if we do that, then it completely changes. It's not really output stream anymore. It behaves differently. I'll quickly go through that. You can add a write listener that will have an event on write possible that will tell you can write now. For the rest, in that output stream, you have to call isReady, and if isReady says OK, then you can write, call the regular write. You can do it once. After that, you have to check isReady again. If isReady says OK, you can do it again. If isReady says no, you have to be quiet. Because if you write then it will get upset and crash. But what it will do, if the moment it says is ready is false, it will schedule an on-write possible event. So then you have to wait, or somehow wait until that on-write possible comes, and then you can write is ready, etc. So, and that kind of shows how complicated this is. The blocking code is so straightforward, and this is not because it's badly designed or something. Well, some things are a bit weird, but it is designed okay, but it's just complicated. You have to think about a lot of things. So in that case, that kind of falls flat, because that's just not gonna work. Because if we look at our code, we have that collector, right? That collector that loops there and writes. That's not gonna listen to isReadies or wait for on-write ready. We can't communicate back up the stream to the database driver like slow down, give me more, stop, continue. That kind of thing, we can't do that. So this is just not gonna work. And this concept that we're talking about here is what we generally call back pressure. Yeah, so and in this case, what we want is have a database and our application server and a client, and as the data streams from the database, we need to balance those speeds, right? So that it is not producing a lot of data, and the application server has nowhere to put it. And that's this sort of the most simple example of that, but it does take it's a lot more complicated than it seems. So in this case, what I'm using is a really small database, so it really doesn't matter at all. But if you have like millions of rows here, you don't want to take all those rows out of the database if you have nowhere to put them. So reactive streams has an advantage, because not only can it do more results, but it also has back pressure. It has a model where you can also communicate from downstream to upstream to balance that speed. So we can do it in reactive streams, but ADBA doesn't really like reactive streams. It uses completable futures, so that's a bit of an issue. The other candidate for today is R2DBC. It's from Pivotal. It's part of the Spring Reactor ecosystem. It's based on the reactive streams, and it is pretty new. It's from 2018 sometime. So it hasn't been around much, and honestly, it also needs a lot of work still. But this one really embraces reactive streams. Everything is a reactive stream pretty much. So let's look at our example in R2DBC. Creating the connection is very, very similar. Also, this one, the first line, I create a response subscriber, and you can look it up. It's a nice wrapper, and that wraps the whole is ready, etc. The non-blocking servlet API inside of a subscriber, and that's a subscriber that will tell when it can take data and when it can't. So this is a really nicely generic thing you can use in any servlet, and it will just use that back pressure. But first, we need to have that data, right? So we create, we call create on the connection factory. That will create not a connection, but a mono of a connection. So it will, you get sort of a future, but it will have a connection at some point, because as we said in the beginning, you can't really make a connection. You can initiate the making of a connection, but when it actually happens is not up to you. So at some point there is connection, and then it will call the flat map many. I'm really not going into the reactive programming here now, but we create a statement, we execute it. Again, that will initiate a stream of results. We map it to use, and this is a different map. It's not just the kind of map you use here. To get out the field we want, we take out the bytes, we put in a byte buffer, and then we just pass it on to this subscriber. And then it will just do its thing. And this thread just can return and just stand back and watch the data flow. So that is quite okay, and I think it also, this is doable. I mean, it's still far from trivial code, but it's still out there. Need to skip the next one. Yeah. So, but then while preparing the talks, then all of a sudden I hear, oh, ADBA has changed its mind. They do want to use a reactive stream because it is a big thing to leave on the table. That if you have a huge data set and you want to call it, that you can't use downstream non-blocking code because it will just flood your system. So what does that look like? I found some source code somewhere, and it mixes completable futures and reactive streams. And that's an interesting choice. It seems to work, but the API gets a bit messy because you are using two similar but fundamentally different things. And also, I have the impression that the drivers are a lot more complicated. So let's have a look at Reactive Streams ADBA. So we have, again, we do the, it's pretty much the same. The difference here is that we call a row publisher operation. And that will publish it to a certain flowable in a way, or a flux. And then we can subscribe to it, and then we can submit it, and then we still get that completable future. I don't know why, because as you see, it's unused because I kind of ignore it. It seems okay, but it is confusing, and I asked it on the mailing list. I got only crickets, so I don't know. But what we can do then, we can use the here I converted to a RX flow, and then I can just do the same thing I did before with the other one. I just map it and put it in the same subscriber, right? So it does work, nearly. What happens here is that if I look at all the options we have, they are all very much work in progress. You shouldn't really take it near code. I only looked at the Postgres driver because life, and even for this hello world style of application, I had to file bug reports for both. So it does need work. It also needs to do some serious benchmarking because I didn't do that. I didn't really check, does it help? And as I said before, the advantage of non-blocking really only show up when you have a bit of scale. If you just have one machine that sits there and you fire a lot of load to it, and it's just one request at a time, it doesn't really help that you can save one thread's time. I do think R2DBC has a lot clearer idea what it tried to do. ADBA seems to be still, at this point, after all those years, really unclear on what it wants. And ADBA is really quiet. I send mails and I file bug reports, but mostly crickets. R2DBC also moves a bit faster, more is happening, but it does really embrace reactive programming. If you don't like reactive programming or you don't want to go that way, yeah, that's not going to work. So you need to like that. So then the question was to me, like, is ADBA doing okay? Is it cancelled or something? And what I did do in a not very scientific way to find out if it's okay, I searched YouTube for talks, right? So but I only got misspelled ABBA clips. So. But I thought that's a little bit unfair. ABBA is really a mainstream phenomenon. This is like a niche even within the Java community. So I add Java. Well, and I found a few. Yeah. So I got one talk, another talk. This one was pretty recent, but then more ABBA, and now slowly more ABBAs keep creeping into my YouTube playlist because YouTube believes I like that. Anyway, but also if we zoom in. The amount of virality is limited. there are 11 views. Here there are 126, so the number of comments is still stuck at 0. Yeah, you could just file a first comment, would be funny after half a year. But this is a while ago, this was in May. So now, 20 views. So most of those are mine, I guess, for making those slides. I don't know exactly how the counters work. But yeah, so so there is not really happening a lot, and I don't know what that means, and nobody tells me, so it is what it is. So, in conclusion, I would like to reiterate that we are really used to wasting threads. There are I just feel it, that there are so many machines that the threads are just sitting there, and they're just unhappy, and it's wrong. So, yeah, let's have a look at that. And also, as I try to show, you don't need fancy frameworks, right? You don't need to, well, you can only do this if you use Vertex or Redpack or whatever. This is just really basic code that can be a decade old. And then you can still make headway. I mean, still, the reactive JDBC drives are still pretty new. But regardless, there are a lot of drivers, for example, like the NoSQL drive, the MongoDB driver, really good. And if you have a servlet that reads from MongoDB, it's amazing how much difference it makes when you can use a non-blocking one. So, and also, you only need to change where the blocking code is a problem. It's not something just for greenfield applications. For the rest, I have a bit of a demo. I can show you that. I need to tell you, though, that the entertainment value is a little bit limited because all of the examples return the exact same thing. Let's see. So the Java code you saw was here, git status, everything good. Okay, so I can build it. Nothing fancy. And from there I have a little bit of, is it readable, sort of? I have a little bit of a Docker Compose file that will build a local server, little server. And it will start a small database with some fake movie data. The Docker file looks like this. It's really small. I just take a Tomcat, and I copy the result of the Maven build. So I do a Docker Compose build, and I do a Docker Compose up. Yeah, okay. And it does its thing. It creates the data. So then, I have a little bit of a script here to peek. And for example, the first one we did, the blocking one, is the first curl. And not surprisingly, that gives just a list. Well, and if I do one of the other ones, yeah, it's the same. So, so yeah, I should have maybe made it something fancier, but it's kind of the point that it doesn't need to be very spectacular in that sense. Yeah, and finally there were some issues. For example, if I use the ADBA non-blocking back pressure one. It kind of seems to work, but if you look at the server logs, it's not that happy. And that is because the driver it's just not implemented yet that it really actually listens to back pressure. It says it does, it doesn't. So it always loses a few. So in most businesses that's not really okay, but in demo business, if I didn't show you this screen, you all would have believed it. So for demos, it's fine, but not for much else. Well, I think that pretty much concludes it. Yeah, so that was all. Let's have some questions. Cricket? Nothing? All right. Well, in that, oh, yeah.
Maybe it's not totally related, but do you think that solutions like Kotlin coroutines will make people write more non-blocking code?
Yeah, I think so. I think so. And I mean, that's what we have seen over the years, that the more it gets a bit more pleasant to write non-blocking code, then people are actually willing to do it, because the price of blocking code is not new. It's not new that is an issue, but just no programmer wants to do it. Everybody's like, so yeah, I do think it makes a lot of difference. Anything else? All right, that concludes it. Please rate the talk and see you around.